chips and so on, it will be he moved from a place, okay, let's say starting with a K place, okay, and then he used what kind of transport? He used a boat, and then he came to Mumbai, then he visited bank, and then he made calls from one number to another number, and then he entered the Taj Hotel in Mumbai and so on. So every day they should keep on observing how many times in the month of November he had done that, made that phone call from one phone call to another one, and how many times he had made the transaction, okay, and how many times it entered Mumbai, and so you can generate rules. Having made a call from this number to the other number, and then entering Mumbai. So all such rules can be generated, more than 80% chances, then he suspects some activity and then takes some action. That's what it is. So of course, US, what they have been doing is, after the 9/11, everybody they would just arrest. That also should not be done. Because somebody might be just going to Washington DC and then transferring huge sum of money and then going to Florida for a vacation. A rich businessman can also do that rather. So having found some suspicious activity, they should double check whether he is a businessman or a terrorist. That should be done. So you can be used very effectively for terrorist, monitoring terrorist activities. Then also for finding associations in studying behavior of the enemy during war, how that movement takes place. The Kargil war, we knew that something movement is going on rather. They could have observed day-to-day activities. From this point to this point they are moving and so on. Data mining can be very effective in finding the movements of enemy during war. And this is, Vipin Kumar is another, in fact, there are many Indians who have done a lot of work in data mining. Vipin Kumar is a professor in the Department of Computer Science at the University of Minnesota. There's a very famous project called MINDS, Minnesota Intrusion Detection System. What he developed was, that is, how to, so in this case, it is no longer an MBD or an MTD, it is a kind of data for the intrusion detection data. Here, what is that? Source IP is given. The number of, the starting time, the destination IP is given, and the destination port, and the number of bytes transferred. So you can find kind of, the University of Minnesota can give the minimum support, okay? And then the minimum confidence. You can generate different rules. So what is the chances that the number of bytes transferred from this source IP to the destination IP, if that is, these are true, what are the chances? With what confidence I can say the number of bytes transferred is more than a certain amount? Different kinds of rules could be generated, and then you can find the intrusion detection. That's possible. It's a working system. And again, total information awareness, DARPA projects, all of them, they say that, okay, if you want to write a new project, go to DARPA model. That's a standard research project. This is the US Defense Advanced Research Projects. What is the main goal there? The main goal is to identify terrorists. What do they do rather? Capture information signatures and look for terrorist-like patterns of activity. That's what is the goal. And also it could be the associations. What is the association between the financial, medical, communication, travel and other records? All could be combined and then find terrorist-like activities. Now, having talked about association rule mining, there is yet another very important technique of data mining, which is called classification. So classification is done by two groups. they always compete with each other. The statisticians and the computer scientists, they claim that I have done it first and he has done it first, but without the help of each other, nothing can be achieved. It's classification is the most common technique in machine learning and data mining. What is done in that case? You have, let's say, we have a kind of training set is there, some of the records which are for training set. We know the class label. What is many patterns are given to you with all features are there, and the class label is given. That's called a training set. And the test set does not contain any label, it contains only the features. And given the training set, you have to develop a decision, your classification model, and then use that model to test the test data set. That's what it is. For example, let's say a typical classification example could be, like you have the tax refund, the marital status, taxable income, whether he is a cheat or not. So in this example, we have what's called 3 features. Forget about the first column, which is nothing but the serial number. The 2, 3, 4 columns, they are the features. What are the features? They are refund, marital status, taxable income. And so on top I have written categorical. Categorical data means it is just an yes or no data. And the single, married, that's also categorical data. And continuous data, that is taxable income, is a continuous data. And the last column is a class label, whether he is a cheat or not. Based on this training data, not only this much training data, there will be volumes of data, and then based on this training data, you develop a classification model. There are 2 types of models. In data mining people, they use the decision trees. In the machine learning people, they use neural networks. So any of the model, any technique could be used. And then, so based on this training data, develop a classifier model. And then, when you want to categorize, on the right side, you find that there is a test data set where you don't have the class label. So the first thing is, you use this training set and then learn a classifier, build a classifier model, and then when the test data you give, and then find out test set you give, use that model and find whether he will be a cheat or not. So in this classification, you have to know the data with a label. As I said, the decision trees are the widely used by data mining experts because it's simple to use. And basically, after constructing the decision tree, you just have to use the if-then rules. That's what you have to use. Like we have, suppose we have used a lot of data and then analyzed and come out with this decision tree model. Here, what is given here is, in this case, the root node, root of the tree, salary less than 1 million. On the left side, it is a S. On the right side, it is a no. If the salary is less than 1 million, and if the profession is teaching, if it is S, then he is a good customer. Identify, categorize whether he is a good customer or a bad customer. Okay. So if salary is less than 1 million and the profession is teaching, is a good customer. If the salary is less than 1 million and the profession is not teaching, he is a bad customer. On the right side again you find that salary is less than 1 million and age is less than 30, he is a bad customer. If the salary is greater than 1 million and age is greater than 30, he is a good customer. That's what is it. So, you can frame if-then rules starting from the root of the tree. Directly, I can say if the salary is 2 million, okay, and then if the age is 35, any of the students could answer this question at once? if the salary is 2 million and the age is 35, then he is a bad or a good customer? He is a good customer directly on. Of course, we have used many techniques for constructing this decision tree, and then the test data, you can directly traverse the tree and then find. There are many various algorithms for this. For some of the algorithms which okay, I would like to show you. This is another. There is those who want to work in classification for the students. Just to give you there is called University of California at Irvine Machine Learning Repository data sets. If you go to that, there are a variety of data, whether you name from inventory data or market basket data or biological data or the stock market data, anything you get. It's called University of California at Irvine. They have these data sets. And there is another site where IDA, there also you can get a lot of data sets for pattern classification. Then, so this is one of the benchmark data sets taken from UCI machine learning repository data sets. The data set is about the age of the patient. There are 3 attributes and features, they are the same thing. Database people call it attributes and data mining people call it features rather, okay. So here, the age of the patient at the time of operation and patient's year of operation, number of positive ancillary nodes detected. These are the 3 features. And there are 2 classes. One is the patient survived 5 years or longer, and the second class information is patient died within 5 years. So, this is how the data set looked. The first column is serial number, we'll forget about it. The second is the age, year of operation, number of positive ancillary nodes, 3 features. And then the last one denotes the class information, whether the patient survived 5 years or longer or he died within 5 years. So if you find this using any of the standard algorithms like the C4.5 rather, and so if you construct a decision tree, you find that if the year of operation is greater than 67, then you can directly conclude that patient died within 5 years. Otherwise, if it is less than 67 and the age is less than 46.5, the patient died within 5 years. Else, it is patient survived 5 years or longer. Can you observe some very interesting feature? The decision trees can also be helpful for finding the important features in a data. In a biological data, it's extremely useful. And see, how many features were there in this data? There were 3. But when you see this decision tree which is constructed, it has used only 2 features. What are the features? One is year of operation and the age. It says the number of positive ancillary nodes, although the people have collected the data about it, it is of no use for the finding the diagnosis rather. So that means I would say out of these 3 features, 1 feature is of no relevance in the classification process. This can be effectively used not only for pattern classification, for feature selection also. Which features are important for this rather? That is also, it can be used. And decision trees, like lot of research has gone on. You can Google and see like people, the first thing which came up was the ID3 algorithm, then the C4.5 came, then there is a called SLIQ developed by IBM, and if you just Google my name, you can find we have done a lot of work on improving upon the SLIQ algorithm, and we have developed our own measure called distinct class based split measure. Whenever you construct a decision tree, you need what is called a split measure. How to split the nodes rather? The ID3 uses the entropy, C4.5 uses the gain ratio, SLIQ of IBM, they use a Gini index. We have used we have developed our own measure called distinct class-based split measure, which has appeared in pattern recognition along with Ravi Kothari of IBM. And we've also come up with the fuzzy decision trees, because sometimes you're not very sure, crisp decision trees are not possible. In that has appeared in IEEE SMC rather, all this. But all this, lot of research says that if you construct decision trees of too much depth rather, then you waste a lot of time in traversing in the testing phase rather. That should not happen at all. There are two ways. Either you construct efficient split measures or you have pruning techniques. What is a pruning technique? You don't chop off the entire tree. Chop off up to a certain level that even if you forego, let's say 1% accuracy, you save a lot of time in the testing phase. So chop off from the root up to a certain point so that you do not forego so much classification accuracy. At the same time, you save a lot of time in the testing phase. This is what is called pruning in decision trees. Yet there is a third kind of technique in data mining, which is this clustering. I would call it as two kinds of technique. One is classification, which is supervised learning technique. Why it's supervised? Because I'm given a training set where I have given for every pattern, I've given the number of features and the class information. In the Haberman survival data, what did we find? We had the class information like whether the patient died within 5 years or he survived beyond 5 years rather. That's a class information. But the cluster, very often we are given data, a new kind of environment is there. I don't know the class information at all. But I want to group into certain chunks and then I want to see which group is some kind of grouping I want to do. So this is what is called unsupervised learning. Clustering is a third type of technique which is used in data mining, which is called unsupervised learning. This is a variety of applications because many times we don't know the class label. I would like to group certain things. It's an unsupervised learning technique. Like what is the basis behind it? I am given a big chunk of data. I want to group based on similarity and the proximity measures. The similarity proximity measures could be Euclidean distance, correlation, Mahalanobis distance, any kind of distance measures could be used to group the patterns. So I can group this big chunk of raw data into smaller chunks based on the similarity and the proximity measures. Where all it can be used, variety of applications are there. Discrimination problems, data compression and information retrieval, crime hotspot analysis. In fact, I was fortunate in getting a project from National Crime Records Bureau from RK in Delhi, and we have successfully given them the solution for the Karnataka